using spatial-temporal cues to enhance force feedback for colonoscopy.
Colorectal cancer is the third most common cancer in the U.S., and the current clinical standard for detection is colonoscopy. Traditional endoscopes used have limited to no haptic feedback, which can lead to events such as looping. These events can cause significant damage to the local tissue as well as discomfort for the patient. For this project, we propose integrating force sensors on the colonoscope to allow the physicians to determine if they're in contact with the colon wall, and then they can navigate accordingly, minimizing damage.
We fabricated our pneumatic sleeve with 3 chambers parallel to the arm. We designed it to provide an adjustable fit for every size. Then we put 3 force sensors around an empty can to simulate the force against inner walls of the colon.
Here we can see the 3 separate breadboards, each breadboard correlating to a pump that correlates to a pressure sensor. One Arduino board is used for each pump because it was not possible to change the address of the pressure sensors, disabling us from assigning multiple sensors into a single SCL port. As seen in the schematic, this circuit consisted of 3 pressure sensors, 3 force sensors, 3 Arduino boards, 6 diodes, and 6 resistors. Here, force is applied to a pressure sensor, and the correlating chamber is inflated based on the amount of pressure on the sensor.
Our software detects when the force exerted by the colonoscope exceeds a safety threshold of 0.4 newtons. When this value is surpassed, the pressure within the chamber is checked. If the pressure is less than the maximum value set by the user, the solenoid valve and the pump will activate to inflate the chamber. Once the pressure reaches the maximum value, the pump will turn off for the safety and comfort of the user. When the force drops below the safety threshold, the solenoid valve will open to allow the pressure to dissipate.
For the test, we have a table that lists every combination of chambers that can be actuated. The user then calls out the numbers of the force sensor or corresponding chamber that is actuated, and then they are scored based on a binary test.